Hello, everyone, and welcome back to our learning journey. Today, we are exploring another exciting topic, which is machine learning. As AI continues to transform the world around us, machine learning stands at the core of many innovations. But what exactly is it? To help us understand this better, I'll pass it over to my colleague Dharmesh, who will walk us through the fundamental concepts and real world applications of machine learning.
Yeah, so thanks, Saria, for the brief intro. So, we are going to explore machine learning. So, in today's world, it's transforming businesses, healthcare, and even our daily lives. But what exactly is machine learning? And that's what we are going to find out today. So, my aim is to give you a clear overview of machine learning. What is it, how it works, and where you see it in action in our daily lives. So, without a further ado, let's get started. So, let's start with the basics. So, you probably heard about artificial intelligence, or it's referred to AI. So, think of as a broader concept. So, AI is a broader concept where we want machines to do the things that typically requires the human intelligence. So by definition, that is called AI. And machine learning, or also referred as ML, is a subset of AI. You can see it in this Venn diagram. So machine learning is a subset of AI. So instead of explicitly programming a computer to do something, we give it the data, and it learns to improve on its own, finding the pattern within the data insights without us having spelling everything out to machine learning. So that is the basic difference. If I would have to give an example, then imagine that teaching a child with the to identify the cats. So you don't give them a strict rule book, but what you do is you show them a lot of pictures. Then they gradually learn the feature that defines the cat. And ML works basically similar way. So the core concept is applied here also in designing the ML. So someone might have a question that which way then the machine learning is different than AI. So by definition, you see that ML is a subset of AI or part of AI. So all the AI systems would have machine learning in some way. So yeah, on overall you can say that, but the answer is not 100% true. So if we think about the traditional AI systems, so which isn't the machine learning, so they strictly rely on the like expert systems or defined rules, and that also considered as AI. But ML, on the other hand, learns from the data and adapting, improving the over the time. So machine learning component consists such like statistical models, data processing, and algorithm development, which is slightly different than the AI. So we will go through what exactly and what algorithms are ML using in the upcoming slides. So now let's see the types of machine learning. So machine learning is broadly categorized into three category. You can say that one is supervised learning, second is unsupervised learning, and the third one is reinforcement learning. So we will understand each of them with an example. So let's start with first the supervised learning. So what is supervised learning? So this is where we teach the machine with the labeled data. Now you can see here on the left hand side what is called label. So label is typically the pronoun or the name you give to particular thing. So here you can see the hexagon, square, and triangle, that is called label. And you have labeled data set as a input. So in your data set, every item of your data, you assigned particular label to it. And then you try to give this input to the model training. So model will learn from this data, and uh, you will test this model by giving some test data. So if I give here these two blue and brown uh, items, then the prediction likely to be square as a blue and the triangle as brown. So this would be output. So here the most important thing here would be the input label data. So that has to be proper in order to generate the proper output. So this type of learning or learning models are called supervised learning. Uh, so if let's imagine that training an email spam filter. So you show the system thousands of emails telling that which are spam and which are not. So what the system will do is it will try to learn the patterns that indicate that particular email is spam or not. So like certain words or sender address, it will try to identify. And then suppose you give the new email, or when new emails arrive in your inbox, then it will identify, okay, whether it is spam or not spam. So supervised learning is used for the things like predicting house prices based on the features like size or location, or diagnosis the diseases from the medical images. So that's where this type of machine learning is used. Now going forward, next up we have the unsupervised learning. So here we gives the machine data without labels and ask it to find the pattern within it. So same example on the previous one, but here you don't know the labels. So you just have the data sets, and this data set is not labeled. So that's where you have interpreter. So interpreting this data and passing it to model. So model will just cluster it out. It doesn't know like what it called. So here there are three items. So it will try to see the similar properties it has, and it will group out. So it will prepare three groups, or we can say cluster, but it doesn't know actually what to call. So that's where you have processing, and then processing you will provide the names. So that will be rule based, or maybe some processing will be done, but it will just cluster out, and then you have the identified identical items as output. So this is also used in think of as a music streaming services that groups the user with the similar listening habits. So it doesn't know in advance that what does or what those groups are, but identifies the cluster based on the music people listen to it. So unsupervised learning is great for something like customer segmentation or anomaly detection system. So we also see in automotive in the communication, when something is not proper or some bad actors trying to send the communication, then it will try to identify the pattern within the communication which is not the intended one, and that's where it will identify that or flag this as some communication is coming from the not intended source. So that's where in the automotive ML is used, and in future also this will be a part of automotive cybersecurity. Uh, so yeah, this is more on all unsupervised learning. Then third one, the third category is reinforcement learning. So what is it? So this is inspired by the human learn through trial and error method. So here you can see these are different components of it. Uh, just gonna give you an example that the action which performed is called agent. So agent will try to perform the action, and in which it is trying to perform action called environment. So agent will perform his actions on the environment, and on every success or failure you will reward it with that agent, or you can give negative feedback or fallback state. So consider that this is the maze, and on first step it will try to move left, so that is the correct path, and then you reward it with the some kind of flag that okay, it's positive response or negative response, and based on that next action it will take. So if real world example, if you have to consider on the reinforcement learning, then consider a robot learning to walk. So it's tried the different movement and receives the reward, positive feedback when the move is forward, and penalty or negative feedback when it falls. So over the time, it will learn optimal way of walk. So reinforcement learning is basically used in the robotics, gaming applications or gaming playing, and optimizing a complex systems. So that's where this type of machine learning is used. Now, w- all these three types. So it would be some kind of algorithm working behind uh, to design these models, ML, not models, but ML category. If we are considering the type of ML algorithm which actually implements the supervised learning, then again it is categorized into two parts. So one is regression and classification. So I won't give you like mathematical uh, way like how it's operating, but we'll just uh, explain you via the examples. So then it will be clear like how or where it is used. So first one, let's start with the linear regression. So simple explanation of linear regression is, imagine that drawing a you draw a straight line through a scattered points, and onto the graphs where very basic trends it has. So for example, when x axis is goes up, then also y goes up too. So this algorithm finds the best straight line that fits your data points, and the predict in the future data points where exactly it will be. So where it is used, so in businesses for forecasting sales, in finance for predicting the stock prices based on the simple factors. So it deals when the relationship between the input and the output would be straightforward. So it's not too vague. Then this type of scenarios, linear regression would be used. And this is very fundamental because all the other regression methods somehow uses the linear regression. So if real life example we have to think about, then consider a real estate agent uses the linear regression to predict the house prices. So here input might be the house size, how many square feet the house is, and number of bedroom it has, and then based on that you will decide on the prices. So this algorithm draws the line showing that okay, bigger the house, the cost is more. So if you have sample data, then you can predict that okay, next you have 4 BHK, then how much it would cost. So such kind of prediction would happen through the linear regression. Next would be the polynomial regression. So this is like kind of linear regression, but with the curve instead of just the straight lines. So if the data doesn't fit into straight line, you can add the power to it and make it polynomial. So that's how the mathematical expression it will work. But if we think about with the example, then predicting the electricity uses in the city, for example, usage might be not rise straight with the temperature. So it may vary. For example, it could be sharply go up when it is too much cold, because more heating is required, and when it is too much uh, hot is there, then you required AC. So during this period it will be very high, but in normal days then it will be low. So here there is no direct relation between these two attributes, temperature versus its usage, in straight line. So that's where you have curves, so it goes up and down, and then you can predict, okay, next forecast for next quarter how much it would be, the usage, based on the season or temperature. And the next one is the lasso regression. So this is also a type of linear regression, but think it as like a rope, so that pulls the unnecessary factors out of the picture. So example is a bank predicting default risk. So they have tons of data, like your income, age, credit score, job title, etc. And this lasso regression might zero out less important ones. So for example, what is the favorite color, or by mistaken it is added in the data sets, and it is focusing on then the most important ones. For example, income and debt. So for an applicant, it predict that whether he will be default or not, and helping the loan approval process without getting bogged down with the irrelevant information. So in such kind of application, or such kind of uh, needs, lasso regression is used underlying the supervised machine learning. The last in the regression, we have the ridge regression. So it is also similar to lasso, but instead of kicking out the factor entirely, it just shrink them all a bit. So like turning down a volume on a noisy radio to make signal clearer. For example, forecasting the crop yield for the farmers. So input like rainfall or temperature or soil quality, fertilizers are often impacting making the decision. So in this case, ridge regression shrink the effect slightly, which is which stabilize the prediction. So for a season with average rain and high temperature, it might predict yield that it will 5 tons per acre it will produce. So helping farmers to plan out without overestimating based on the some other variables within the input what we consider. So this was one part of the machine learning algorithms which are used in supervised. There is another category which is called classification. So in classification algorithm, instead of let's say we have number or pricing, we have labeled category. For example, yes, no, spam, not spam, or dog or cat, something like that. So in that first one is logistic regression. So name suggests regression, but it is comes under the classification category. So imagine you are trying to predict if someone will buy the product, yes or no, based on their age and income. So this would be yes and no question, and with the lot of amount of data, then it will classify and learn, okay, whether you will be probably buy this product or not. For example, one more example is hospital uses the logistic regression to predict if the patient has the diabetes or not. So input are like blood sugar level or weight, and the model calculates the probability, for example 70% chances of diabetes or not, so based on the past patient data. So for a new patient when with the high blood sugar, it might predict that likely diabetic patient, helping doctors to decide on the tests. So similarly, next up is the support vector machines, so which is also referred as SVM. so which are building like a fence that perfectly separate two groups, like cats and dog. So with the waste means widest possible gap it between those two categories, it will try to maintain. So if we want to really think about where it is actually used, so all the email providers uses this SVM email as is to identify spam, not spam, or to identify or segregate in different groups. So yeah, for iPhones also you would have seen they have in different groups, promotion groups or your personal, and then spam or not spam, something like that. So here input things like it will think about the words like win or free in your email. So it will see if those words are repetitively more and frequently used, then there will be a clear identification that could be coming from the spam email. So that's where this SVM is used. Next up we have is the decision tree. So picture this as a flowchart where you answer yes and no question to make a decision. Like it's raining. If yes, then take umbrella. If no, then wear sunglasses. Something like that. So consider this decision based tree will be followed to get you the outcome. So that is the decision tree. Yeah, so next is the random forest algorithm. So random forest is like asking a group of decision tree to vote on the answers. So in the previous decision tree, you might have multiple decision tree and you got the answer. Now from that answer, you will say that yes and no uh, to get the final answer. For example, if we think about, then think it as a online retailer uses this random forest to recommended product. So your input would be the past purchases, your browsing history, and customer ages. So each three in the forest votes on would you like it or not like it, and then it will decide the final suggestion that you will be going to purchase this item or not. And the next one we have is the naive Bayes. So naive Bayes is like a uh, detective who assumes the clues are independent to calculate the odds of something being true. So it's look a pattern. For example, how many times the the word frequency within, for example, a email, and then based on that, it will multiply the probability of guessing the category. So it will just based on the small amount of data set, it will try to identify. It will just guess whether this will fall under this category or not. So this is, for example, a review application you see in most of the restaurants review, whether the review is positive or negative. So it will look at the words like delicious or awful in the past review. And whenever the new review saying that delicious or great service, then it will categorize into the positive review. So, and if something else, then it will consider as a negative review. So this will summarize and give proper customer feedback to restaurant to improve their services. So this is where this type of algorithm is used underline supervised learning. Similarly, we have unsupervised learning ML algorithm. So here are the list of the algorithms. So we won't go through them one by one everything, but the most common used one we'll just try to explore with an example. So most commonly used or the base for others also other in this list is the k-means clustering. So imagine sorting a box of mix of candies into groups based on their colors or shape. So K means picks the number of group, for example, three, and assign each candies to the closest group center. So like putting the red candies into one pile and the blue candies into another pile. So where this is used in real life is an online store uses this K means to group the customers by shopping habits. So it look the purchase history, like buying electronics item or clothes, and sort the customer into say the category of the groups. For example, tech lovers or fashion fans or bargain hunters. So whenever the new customers is buying most of the gadgets item, then the algorithm assign this to tech group and helping the store to send or target particular ads to this customer, which is mostly related to technical ads. So that's how the k-means algorithm works. So next, the important one and the famous one is the hierarchical clustering. So this is like you have family trees where you have on top the grandfather, then father, mother, and then children, something like that. It will organize. So either it can be bottom to up or top to bottom approach. So if we see where it is used, consider as a library user uses this hierarchical clustering, organizing the books. So it looks at the book topic, for example, history or fictional, and group them into similar one. So like related groups, for example, history or biography. So if the book is titled with World War II, then it gets placed into history cluster, and which is also part of broader group of non-fictional group. So non-fictional book, and this will help organizing the library structured way. And if the new user comes, then suggest the uh, books accordingly. Then we have the PCA is the principal component analysis. So PCA is like summarizing a long book into few key points. So it take the complex data with many variables like person height, weight, age, etc., and find the most important one uh, to capture the main pattern in it. So reducing the data to fewer dimensions. So it may have many dimensions, but reducing it to most important one to identify the particular pattern. For example, we all use the fitness app. So fitness app uses this PCA to simplify the user health data. For example, it takes the measurement like how many steps you walked or heart rate, sleep rate hours, and also calories burnt in a day. So all of this factor it will consider, and it have to rate like overall activity and rest quality of the person. Then it won't consider unnecessary factors which is not required to identify this particular categories. So when the users will have, for example, poor sleep and high step, then it will consider that their category will be activity level will be assigned to it. So it doesn't require the other attribute here. So that's where this principal component analysis are used. One more important from this list is the singular value decomposition, SVD. So it's like breaking a complicated recipe into the core elements. So this one you might have seen in the streaming apps, for example, Netflix or YouTube's or any other application which serves you the feeds. So it analyze watch history, and breaks into the key patterns like thrillers which you like or horror movie you like, something like that. And then whenever next you try to again log in, or when you come to app, it will try to suggest that what is relevant, most relevant to you or interest to you. So for those underlying, SVD is the algorithm which is working. So yeah, there are many others, but we'll not go through much in the details. These are some of the important ones we discussed. And then next would be the reinforcement learning. So in the reinforcement learning ML algorithm, so there are also many others, but the most common used or most commonly worked is with these three algorithms. So first one is the Q learning. So imagine that teaching a robot to navigate to maze. Now Q learning is like giving a notebook where it writes down how good each move is in the maze in this example. So at every spot, it will just try to note down and then improve on the past, whether it's got reward or not rewarded. Based on that experience, it will try to learn. So, for example, a warehouse robot, you might have seen it's already in action. So, warehouse robot uses this Q learning to find out the fastest path to pick the item. So, it's tried different routes, noting down that one gets it to the item quicker will be the higher reward. So, based on that, after many tries, it learns zip through the completely efficient way to get your product quickly from wherever it's located. And this serves a online retailer or shopping process very convenient. So this uses Q learning underlying this type of task. The next one we have is state action reward. State action, SARSA, is kind of Q learning, but instead of assuming the best future move, it learns based on what actually it has to do next. So, for example, on a very busy elevator where you don't have kind of press button, okay, which floor you want to move, it's continuously going up and down. So by over the time, it will identifies the floor, which floor is the busiest and which floor is not so busier. Then it will try to stop that many uh, seconds at whichever floor is more busier. Then it will try more at that floor and less at the others floor. And whenever it's sometimes keep also the floor which is not uh, too much busier. So in such cases, this algorithm is used. And the third one is deep Q networks, DQN. So it's also a type of Q learning itself, but it is smarter with the brain or upgrade version of the Q learning. So which underlines uses the neural networks to works or identify the final output. So the neural network we already discussed in the last video. So if you want to get overview how it works, then yeah, please check out on the neural network whatever discussion we had in the last video. Okay, so then those were mostly the how underlying algorithms works for the category of the ML. Then now comes to the some of the real world application. So first one here is the computer vision. So computer vision ML powers this facial recognition, object detection in the self-driving car, and the medical images analysis to detect the tumors. So that's where ML is used. The second the use case would be the natural language processing. So it's behind all the chatbots you see and the language translation tools and the sentiment analysis that guesses the public opinion on social media. So that's also underlying ML is used. Next application we have the speech processing. So ML converts speech to text, recognize the voice command, and generate the again text to speech also. So this is the one more use case. Next use case is recommender system. So you see that Netflix suggests so you might like. Amazon recommend the products which is most likely you would like and purchase. Similarly, social media also tell us your feeds. So all those thanks to the machine learning. So how the machine learning is evolved and that contributing to these use cases. But of course, machine learning it's not the perfect. So it also has some challenges. So what are those challenges? So the first challenge is the data quality. So ML models are only as good as the data. So they are trained on based on the data. So if data quality itself is not so good or incomplete or biased data will lead to the poor results. So that is the biggest challenge what machine learning has. The next one is overfitting. So model can become too sophisticated on the training data, performing poorly on the newer data. The next challenge would be the ethics. So biased AI can lead to unfair or discriminatory outcome, like facial recognition use case, where system might be identifying based on their colors. Then this will the ethical problem. That's where most of the governments are having or come out uh, with some kind of rules in place how to operate AI. It's still under progress. So as technology evolves, those also would be worked on to make it more ethical uses. Then the one more challenge we have it in ML is the scalability. So deploying the ML models at the scale can be resource intensive. So it would require so much resources, so much cost. So yeah, scalability of the machine learning models would be one more challenge currently we have. So machine learning is powerful tool, but it requires the careful consideration of these challenges to ensure that it used as a responsibility and effectively. So in summary, if we see the machine learning is a revolutionary technology that already transforming our world by understanding its principles and being aware uh, its challenges we can harness its power for good. So yeah, those were the overview of the machine learning. uh, and if you want to learn about more detail, then now whichever the category suits for your use case, then you can again search mostly online. You will get so much content and then learn on those topic.
Okay, so here I have a question. Here in the challenges, we see overfitting, that the model performs well on the training but poorly on the new data. So, can you please elaborate what does it mean and why is it considered as a problem?
Mhm. Yeah, so that's the good question. So if I may answer that, then overfitting is when a machine learning model learns the training data too well. So it becomes a sophisticated to that specific data that it will perform poorly on the new data or unseen data. So imagine a student who memorized all the answers uh, to a practice test but doesn't understand the underlying concepts. So they will do great on the practice test but poorly on the real example. So overfitting is a problem because the goal is to create model that generalized well in the new situation. There is one more challenge I haven't listed, but that is underfitting. So underfitting also would be opposite of this. So there you design to model to actually work well, but uh, with the less amount of data or misinterpretation of the data, it won't perform that good what you expected. So that's what the overfitting and underfitting in the ML challenges we have.
So I have a question, Dharmesh. When it comes to machine learning, what unique role do you think a data scientist plays compared to other tech roles?
hmm Yeah, that's the good question. So the whatever we discussed does not explicitly mention about the data scientists, but they plays the crucial role in the machine learning. So as a data scientist, as a profession, so their most important task would be the gather and prepare the data used to train the machine learning model. So that is the most important task as a data scientist they have. Then choose the appropriate machine learning algorithm from the given problem. So as we discussed, all the problems will have different use cases, and not all model will fit into that. So whatever type or we have seen, so whatever the use case you have, it doesn't mean that whichever algorithm you choose will work on that. So they should have clear understanding based on the problem, and then according to that, they should properly choose the algorithm to train the machine learning model. So then next the task would be to train, evaluate, and fine tune the models. So it also doesn't mean that when you train particular model, it will work on first go. So they have to iteratively prepare the data, train it, fine tune it, and then the task would be to deploy the models and monitor their performance. So all these tasks would be done by the data scientist and the similar professions. Yeah.
So I also have one question, Dharmesh. How do we evaluate if a machine learning model is good?
Mhm. Yeah, that's the good question. Answer to that would be that we uses the metrics like the accuracy. For example, how often it's right overall. Precision is one more parameter. So how many of items have yes prediction are correct. For example, not falling good email into the spam. One more parameter is the recall, which means that how many actual yes cases it catched, like when it you put it in the spotting fraud items, then how many times it got caught this particular uh, fraud communication, suppose. So answer recall will be one parameter. So we have certain parameters for to evaluate the model, and there would be some metrics also. So for example, we seen in the RAG implementation, we have ragas as a framework which uses this matrix and give you the result. So imagine testing a spam filter, so which is which has the accuracy might be 90% right. But if it is miss half of the spam, for example, low recall, then it's not a great ML implementation or not a great model, because of course you got the 90% accuracy, but you got for only half, and half of the email layer anyway uh, went into the mail email. So that is also not good. So that's where it's always evaluation happens on the different parameter, and that is the job of when we design the model, then when you evaluate, so these of the parameters should be considered.
Okay, Damesh, I have a question. I have also come across the term semi-supervised learning in few places. Could you explain what semi-supervised learning is?
Mhm. Yeah, so that also interesting question. So yeah, even when I was also going through the machine learning, so this terms comes semi-supervised learning. So what basically it means is mix of supervised and unsupervised learning. So where you give a machine mostly unlabeled data, but a small amount of labeled data as an example to guide it. So picture sorting a big pile of photos. So you label a few bunch, uh, for example, like mountains or benches, so or beaches. So some very few in the data sets you label it and give it as a hint for the remaining whole pile of the photos. Then it will model will try to do the unsupervised learning and try to find out the patterns, and then it will try to categorize it. So it is nothing but it's combination of both supervised and unsupervised, because some of the use cases you might not be fitting it is solely in the supervised or unsupervised. So that's where you have to use the mixing of these two ML category.
So, generally, when we go through the ML and specifically for the reinforcement learning, we see that the examples are too complex, like robots or self-driving cars or this kind of examples. So,
Mhm.
are there any simple, like simpler and more relatable examples that can help to understand in much more clear or have a much more clear understanding about the reinforcement learning?
Okay. Yes, you are right. So whatever we discussed, we mostly took the example of this maze or robots in the warehouse when we talked about the reinforcement learning. But it is used in many other use cases or application. For example, consider a learning to play a video game. So the algorithm tries the different action to get the reward for scoring the points and the penalty for losing it. So wherever the video games is designed, and the models is try to play and improve that video game, that's where reinforcement learning is used. One more example I would say is optimizing the website layout. So an algorithm can test the different layouts and track how user interacts with them, rewarding the layout that lead to more clicks or purchase. So that is one more example where the reinforcement learning is used. Uh, One more would be like personalizing recommendation. So recommending all the things, for example, recommending the uh, best product or movie to a customer. That's where this is used. All the song streaming app, you can say Apple Music or Spotify. So they have used this grouping algorithm. So they don't have prior knowledge. So they have the list of categories, but as and when you play the songs, then they knows what type of music you like, and then they will personalize your list based on that. So that's where the reinforcement learning also useful.
And thank you, Dharmesh, for breaking down the concepts and showing us how machine learning is shaping real world applications. We hope this session gave you a clear understanding of how ML works and why it's so impactful in today's AI driven world. If you enjoyed this video and want to continue learning with us, don't forget to like, share, and subscribe to our channel. Stay tuned for more insights in our upcoming episodes. Until next time, keep learning and stay curious.